Yes. So now we are going to see the last topic in module 3, that is YACC. YACC is a compiler generator, parse generator, the same way as we saw as in Lex. Okay, so Lex is for lexical analyzer. At the end of lexical analyzer, we have seen Lex tool, right? The tool which converts the input into tokens and lexemes. The same way, this particular tool will help you to do all the process that we have learned so far. So this is one of the tool through which you can do this conversion of your tokens, the lexemes and tokens into a parse tree. Okay, so far we were in the lexical analyzer stage where in syntax analysis stage where our tokens and lexemes which we get as input will be converted into a parse tree kind of structure, right? That is what your that is what we have seen, how it can be converted, what are the parsing options we have seen, like top down, bottom up, yes, everything we have seen. So that is made as a tool, and this tool will help you to generate that parse tree. Okay, so this is how so we are just this is a session about how this tool works and what are the how and we are going to see an example called desk calculator example, and we are going to see how the calculator program is implemented in this tool. Okay, a calculator is nothing but how if I have if a user given as use input as 1 plus 3, then it should give the answer as 4, right? If some error is there, then error should be displayed. The same way, the simple desk calculator can be built with this tool. Okay, so that is what we are going to see as an example. Just we will see as a brief about these kind of tool. Okay, so the first is Lex with YAC. So here here there are three parts in this tool. First, it will be getting the specifications, okay, and that will be converted into Y tab. Okay, so this is what the specification is. Okay, so specification is nothing but you are including inputting a input file. Okay, so this is a file. Okay, input file with dot y as extension. This translate is nothing but the name of the file. Okay, so YACC specific YACC, the expansion of YACC is yet another compiler. Okay, so YACC specification is first you are going to input the file that is sent into YACC compiler, which gives you a y.tab.c kind of file. Okay, this y.tab.c file was nothing but so inside this YACC compiler you will have LALR algorithm, and that algorithm will give you an output as some algorithm. Okay, so after the output of the after passing through this LALR, you will get an output, right? That is what this y.tab.c file holds. Okay, so when you are giving an input file that undergoes LALR parsing, and it will give you LALR file. Okay, so that in actual happening is LALR happening, but we are telling it as y.tab.c a file. Okay, so after that y.tab.c file will be entering into the C compiler, because it is a C file. It will enter into C compiler, where you will get a.out. Okay, a.out file. What is a.out? A.out is a object file. Okay, it's an object file. Okay, so y.tab.c is sent to the C compiler. It produces an object file called a.out. Okay, that a.out object file is sent inside this input, and you will get whatever input is given inside will be given as output here. Okay, so this is the steps of how the YACC compiler works. Okay, first it will be the raw file will enter, that will be converted into C file. The C file is converted, and that is converted into object code, and the object code is converted into the original parse tree. The output is nothing but the parse tree. Okay, this is how these are the phases how this compiler works. Okay, YACC tool works. Okay, next. Fine. So these are the functions of YACC, where YY wrap means it's the end of an input. These are the additional information of what are the functions that are used in YACC. Okay, YACC parse, lex, error, atoy, and YY text. Okay, so these are the functions that are used inside your YACC compiler. Okay, YACC tool. Okay, here there are in this tool there are three different types of three different sections. Okay, so before that we'll just see this. Okay, YACC, the same thing what we saw in the first slide, the same thing is given here. So YACC specification center, you'll get C file. C file will be compiled by C compiler only. That is entered inside this, okay, and we'll be adding this library and all inside the C compile, okay, and you'll get an output, okay, fine. So there are three parts of YACC program. It is declaration, translation, and supporting C routines or auxiliary functions. You can call this as also as auxiliary functions. Okay. So you would have remembered this Lex tool. The same way here also that a program is divided into three parts. Now we are going to write the program for the tool. Okay. So first it starts with the declaration. Then you have a translation rules and followed by supporting C routines. Okay. So the declaration, what you'll have in a declaration, the declaration, wait, I'll show you. Okay, declaration, it will have a ordinary C declarations, like how you used to declare int A, int B, like the same thing declaration you can have. Okay, sometimes the declaration, here the declaration is divided into two parts. Here the declaration is divided into two parts. One is normal declaration. Okay, so normal declaration, the example of normal declaration is, okay, remember the declaration always starts with percentage open bracket, and inside you'll have declarations. Okay, int A comma B. Okay, then if you want to declare some tokens or constants, you have to use a const keyword. Int A is equal to 20. Okay, and if I want to include some header files, you can also include in this hash include stdio.h, or any header files I want to process the program, I can include this in the declaration, then in the normal declaration part. Okay, okay, so declare some other declarations like tokens, okay, left parenthesis, right parenthesis can also be declared inside the declaration. That is the next part. Okay, the grammar tokens can also be declared in the declaration part. Okay, grammar tokens. Okay, if you are going for a normal declaration like integer and constant, then you have to go in this way. If you're going to declare some tokens, then you have to declare, just you have to use percentage and you have to declare the tokens. Okay, so we'll see in the example. Just this, remember what are the things what are the parts of your program, how they can be used inside your program. Okay, that is what in the tool, that is what we are going to see in this section. Okay, fine. And then that if there is a, then a grammar rule separation, if there is a separation, you have to do this, use this percentage, okay, not to separate the declaration part and the other rule next part. Okay, then is grammar rule. Okay, a non-terminal followed by a colon. Okay, for example, E gives A or B. Okay, if this is your if this is your if this is the given grammar, then how it can be written in the coding. Okay, it can be written as, okay, in the form of head. Okay, use body 1 and body 2. Okay, body 1 comma body 2 comma it goes on, which means if this E is nothing but head. Okay, E is represented as head here, A is represents body 1, B is represented body 2. Okay, likewise you can use this grammar rules. Okay, so non-terminal name followed by a colon produces separate vertical bar, possibly each with additional semantic action and precedence information. Okay, so so in the example I'll explain you clearly. Okay, so here this is how your grammar should be. Okay, so for example, if this is your grammar, E gives A or B. Okay, A gives C. If this is your grammar, this should be represented in the grammar rules only in the form of this. Okay, so I'll show you with example how to be represented. Okay, so in the grammar rule you'll be representing the grammars. Okay, next, after that you will use a separator to separate the grammar rules or the transition rules with the auxiliary functions. Okay, so this is not, last part is called as auxiliary function, where your additional part or the main works. Okay, there must be a lexical analyzer name called ylex. This is mandatory, commonly accomplished lex y.var. Lex is a program used to build Alexa but can be handwritten. Okay, so we'll see this with an example. Okay, so your program should have a declaration part separated. After that you have a separator where you will declare a normal declaration as well as your token declaration. Then you'll have a grammar rule where you will be defining your grammar, how the grammar should be, then followed by your auxiliary functions. Okay, we'll see with an example. So this is an example. Okay, so starting, this is the given grammar. Okay, E gives E plus T or T gives T star F slash F or F gives open bracket E close bracket or digit. Okay, so here E represents the expression. Okay, okay, E represents expression. Okay, E expression. Okay, expression. Okay. Okay, okay. So give you, oh, just a minute. E means expression. Okay. Okay. T means term. Okay. F means fact. Okay, so this is what your factor. Okay, it is called as factor here. Okay, so I hope you could see the screen. Just a minute. Fine. Okay, fine. So here I told you this part is called as, declaration part. Okay, as I told before, this is your declaration part, where it should start with percentage open bracket and it should end with percentage close bracket, right? That is what given here. Okay, see here, this till this. Okay, so here you have, I have included a, you can, in the declaration part, you can have a normal declaration which has some data types, some constant value you can declare, as well as you can declare your header files also. So here I have used, they have used to declare a header file called ctype.h, which helps you to do this function. Okay, so in order to do this, we are using this ctype.h. Okay, for this particular, this is a calculator program. Okay, this is very, very important. Okay, you may get this question in your question paper. Okay, so you may get this question. So this somehow you just remember this program and explain how it works. Okay, fine. Hash includes ctype.h is declared here. It's a header file. Okay, header file. So in your paper, you must write this program as well as you, what are the things you have given inside, like declaration part. This header file included. Okay, so see here, this it help you to find this is digit. Okay, see here, this thing. Okay, it helps you to find this particular function, so we are using this header file. Okay, like this you write the program and start giving the explanation simultaneously. Okay, one by one, line by line. Okay, then after the declaration, the normal declaration gets over, you have to declare the token. Okay, the token digit is declared here. Okay, token digit, this is declared here. Okay, this particular part is declared here. Okay, this is a normal declaration, this is your token declaration. I had told declaration happens in two ways, one is normal and one is token. This is a token declaration. Fine. After that, you have a separator called percentage. See how the token declaration is declared. Okay, declares the token digit for use in grammar rule and also in lexical code. Okay, so since digit is the is declared inside the grammar, so we are using this token. Okay, next is line expression. Okay, n. Okay, what is it, this particular line, this is, okay, this part is called, okay, after the separator till the next separator, this part is called as translation rules. Okay, this is the part where you're telling or implementing these translation, these rules. Okay, so this is what we are doing here. Fine. So see here, line expression slash n printf n. What does it mean? It is just telling the compiler or the this tool to read the input from the user. Okay, so this line can be expressed followed by a new line. Okay, so the line, it says the line can be expression which should be which is from the new line. So whenever there is a new line and enter, then that should be considered as an expression. So okay, so that is what it is, just reading the input from the user. Okay, this first line. Second line is expression. We are declaring, we are telling the grammar rule. E is called as expression. That is what given here. So instead of this arrow, they have given with colon. So this is what specified in the rule, in the grammar rule. Okay. So expression, okay, colon, instead of arrow, we are specifying the colon. Okay. Expression plus term. Okay, see here, E is called expression, plus is the plus operator, T term is called the term. Okay, bracket kulla we are using this. Okay, this is called a semantic rule. What is it? Dollar 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 represents the E. Okay, see here is equal to dollar plus dollar one, which represents the first position of the letter, which means we see here this dollar dollar represents E. Okay, dollar one means the first positioned letter. Okay, that is E. Okay, then plus dollar three. Why it is dollar three? Because this is dollar one, this E is dollar one, this is $2, which is not explicitly mentioned. Okay, then this is $3. So the third position letter is mentioned here. Okay, this is how you will be representing the semantic rule in the tool. Okay, so this is what given here. Okay, so here you are representing in the words. Okay, expression means e gives, okay, expression. So this is e gives e plus t. Okay, or you have to represent in the semantic rule form. Dollar means e, give equal to means gives. $1 is e plus t. Okay, we have declared, or we have included this term, this particular word inside this. Okay, now you have to use this. What is this term? Or term. This is or, and term is given. Okay, it is very simple. If you, by seeing, you would have thought that it is very complicated, but just look at what is given and with the along with the expression you got. Okay, so this is how you can do it. Okay, fine. So now we have declared or entered the first term, right? Now we are going to include the next. Okay, what is that? The next word is called, 1 minute. Okay, next is your term, right? Okay, next is your t. Okay, so t is nothing but term. Term gives term star f, the same thing, term star. So when you're specifying an operator, you should be a single colon followed by f is a factor, which is already told, and open bracket la term ku badala you are just putting $, equal to, what is $1 is term star, $3 is nothing but a factor, close bracket. Okay, then or you have one more f. Okay, so or f is nothing but a factor. Similarly, last thing is factor is equal to factor colon. Okay, so you have to represent each thing is considered as a symbol. Each symbol is considered as a symbol in your syntax analysis, right? So you have to specify everything. So open bracket, some expression, e is expression, and close bracket. Okay, so open bracket, $, is nothing but f gives. Okay, what is $2? It is 2, because this open bracket is $1, e is your $2. Okay, $2 alone is specified here, close bracket, or digit. This digit is declared as token here. Okay, so now we have initialized the translation. We have input, we have entered the translation rules, okay, or production rules. Fine. So now you have the separator. Okay, so see here, so that is what given at the right hand side. Semantic rule, default semantic rule is $1 is equal to 1 is for single line production. Okay, so after this you have a separator, then you have this last part called auxiliary function. Okay, so your main function. So here while x is mandatory, int c is equal to get character. So your user will enter a character, then if the character is a digit, you are doing this function and returning the digit. Okay, that is what, this is the main function. So lexer user include lex.yy.c, here use yy routine because by lex, and lexer user c variable yy val communicate the attribute value. So this will communicate what value should be entered or what you got, what should be returned. Okay, this is what given here. Okay, so this is the main function, or this is the calculator, simple calculator program. Okay, so and the main idea of this is, so see here, the same thing is given in the as an explanation. So here the declaration part, where the section contain the include statements include C type, that cause C processor to include standard header file C type head.h that contain predicate is digit. So we are using this is digit function in the yy-lex. Okay, this part. So yy-lex we are using this function. So we are, in order to use this function, this header file is included. Okay, next the tokens declared in the section can be used in second and third parts of YACC. So here, okay, so here the tokens that is declared is used in second part. Fine. Next is if the lex is used to create the lexical analyzer passes token to YAC parser, these tokens declares are also made available to the analyzer generated by the lex. Okay. Next is translation rules. How the rules are. Okay. So the rule should be in this form. Okay. Head colon body 1 semantic action 1 body 2 semantic action 2 till body n, the same way. So this is body 1 expression plus term semantic rule. This is body 2. Body 2 doesn't have any rules after that, so a semantic rule, so we have left as such. Okay, if not, you have to specify that also. Okay, so here the semantic action $, represents the the dollar specific refers the attribute value associated with the non-terminal of the head. Okay, so if there is $, represents the non-terminal values like e, T, and F, and $I refers the value associated with the ith grammar. For example, so okay, this $dollar represents the left hand side. Remember like that. Okay, if you are specifying the right hand side, non-terminal in right hand side, you have to specify dollar and its position. So this is at first position, so it is 1. So here one more non-terminal. So T is a non-terminal, so you have to specify dollar with its position. What is its position? So this is 1, this is 2, this is 3. Okay, likewise you have to specify. Okay. Fine. So now the, okay, so that is what given here. Okay, last part is your supporting C routine part, and what are the functions. Okay, so it is what it is. Okay, so this is what your simple uh, calculator. Okay, why you through how the YACC tool accept this calculator and how it works. Okay, and this is very important, so I request everyone to understand and write the program. I hope you understood this. Thank you all.